I can share a little bit why do we have this like brainstorming session. I think the idea essentially came from Key Chef in one of our preparation meeting a while ago. He said maybe it may be a good idea to towards the end of the workshop to have a session where people just can discuss what would be the interesting direction or topic that was pursuing. In the intersection of this society, climate change, and sustainability, and also maybe just a little bit summary of what which group are doing what in this area. And then at the end of the workshop, and maybe we can compile a document that we can share online. So just summarize all these observation and discussion that's out from this brainstorming session. And of course, Norman added that we could also brainstorm how this workshop, how people want to see this workshop develop further next year or beyond. So I think it's a very nice idea. I think some of the PhD students would love to see some discussion of on the direction and topics that who knows, they may feel exciting, and then maybe try 1 or 2 out in their PhD study. So Sonia, you want to go ahead.
I was just thinking, I mean, climate catastrophe, it's more like a crisis. A crisis is developed up and down, and if we don't behave, there won't be a downwards development anymore. I think it has taught us that whatever we do, we need to deal with it through using all the disciplines available. Just as we saw in the last talk, right, where theater people and computer guys and whoever collaborate together. And we are doing this in our projects too. And this is something that I missed mostly in the workshop today. Unfortunately, I have to confess, I couldn't participate for the whole time because I had to do some workshop hopping. But I scanned the talks, and I still have the notion of pretty, let's say, energy informatics stuff. Maybe I'm wrong, then it's fine. But for a workshop like this, I would love to go into the direction of being really not only interdisciplinary. So I'm looking at problem from this angle, I'm looking at this from that angle, but truly transdisciplinary, where you merge the methods and produce something commonly together, which is really a tough job.
Yeah, I think absolutely. I think it's a nice idea. I mean, but I also agree to that it seems to be a challenging job because you really need expertise on both sides, multiple domains, and then they really need some chemistry going on there to actually apply to come up with some there's a project or research or study that is not just plug and play, but it's also synergy between them. I think, yeah, I think it's really, it will be really cool though. Yeah.
So I have one question to the panelists. As during the workshop, a couple of talks pointed out to this, that the meaning of different terminologies is very different to different people. Like sustainability in Africa and developing countries like Pakistan may mean that you have a project that is sustainable financially on its own and without requiring constant additional funding and things like that. Here, like, we generally talk about sustainability in terms of carbon reductions and things like that. And similarly, there would be like other concepts and stuff which even within a community that works on very similar stuff, they are very different. So how can we, like, do you think it's like necessary to bridge this like gap? For example, there are many other terms that, for example, I recently heard in a meeting, climate resilience, that is different than like maybe preparing, like there was some discussion about preparing for climate change versus climate resiliency versus sustainability and things like that. So maybe there is a need to, because we will have a community that is coming from very different backgrounds and working on very different topics. So maybe there is a need for some like
Okay.
terminology that is consistent for everyone.
So Colleen, you want to say something? Okay.
Yeah, so this kind of gets a bit into some of what I've encountered with my work at VMware. There's some industry alliances that we're part of, and I help co-lead two of them. One is about Green G, and that's related to sustainable, environmentally sustainable next generation communication networks. And the other one is it's a mouthful, Societal and Economic Needs Working Group. And that looks at some of the other aspects. It encompasses sustainability, but it gets more into economic sustainability, quality of life, climate resilience, as we're talking about. And this kind of gets into, this was new to me, kind of when starting this work, the United Nations Sustainable Development Goals. So a lot of their sustainable development goals are focusing on more general things like gender equality, and making sure that people are employed, and a lot of these things that people will be thinking about in developing nations, while still also encompassing environmental sustainability. It's specifically pointed out as one of the UN SDGs. So when we need to clarify between them, we personally use the term environmental sustainability instead of just sustainability in general, and maybe preface other types of sustainability with economic sustainability. They are all related in very different ways, but kind of just 2 cents from, I agree that it can be confusing, and this is how my two intersecting groups work on disambiguation. And for those of you here who, like me, maybe hadn't heard of the SDGs, they're pretty interesting, so it's worth going to read up on them.
Okay, cool, thank you, Colleen. George?
Yeah, first of all, I 100% agreed with everything Colleen said. That was amazing. What I was going to say was that when we talk about this community building, and you were asking kind of about this workshop and SIG Energy and WeCan', et cetera, I think there's one thing that we're going to have to figure out as when you think of environmental sustainability, or I guess if you think about economic sustainability, which is I think the term you just used, but especially environmental sustainability, we want to create a community of people focused on that. And that's important. And I know that there's some venues like Compass, SIG Energy, et cetera, that are kind of bringing together interdisciplinary people, different parts of computer science at least, to focus on this. And that's important. But it's also kind of important, I feel like, to go into the subfields as well. And so, for example, if you look at the kind of NSDI, SIGCOMM, OSDI, SOSP, the systems builders, if you don't bring to them this idea of sustainable design, what you're going to end up with as a group is a community that focus on metrics like scalability, cost, performance, traditional metrics of success. And if sustainability or environmental sustainability is not part of that, then that won't be valued. And so this is where I feel like there's kind of a tension that we want to create communities of people, but we also want to go to where people are. And I feel like we have to kind of figure out a way to do both without splintering or diffusing our efforts, et cetera.
Yes, so I would like to add one thing here. So that is where we recently felt that, like, with some of our publications that targeted carbon reductions or sustainability and things like that, and making computing applications carbon aware, some of the feedbacks that we received was, okay, this seems to be a solved problem. Google is going 100% green or something like that. And there were some other criticism that, okay, this seems to be asking too much from the application developers and things like that. Like, they won't be willing to do that. There is no incentive for that. So even within like pure systems community, I hope with workshop like hard carbon, it would be more apparent to like a broader community, but it is still, it takes a lot of convincing to make people know that, okay, this is a new paradigm of system design and it is important, and there are other metrics beyond traditional energy efficiency, cost, and performance that needs to be looked at.
Right, and I was using systems only because that's where I come from, but everything, design, usable design, languages, algorithm design, it feels like you need to kind of infuse all of those with this concern, because if we want to have a computing industry in 500 or 1,000 years, which I'd like to think that we will still be, doing that, it's clear that we're not going to be able to build the same way we have been.
David?
Yeah, just to build on Noman's point, I think a real problem in computing research is that, there's an implicit kind of cost calculation people do. Like, people won't do this because it costs money. It's not profitable. And that's in part because industry is so deeply embedded in research communities. And so really computing has a huge challenge in separating out kind of research challenges from cost optimization, right? There are interesting research challenges in sustainability that are independent of cost. And, the cost kind of mechanisms or, cost implications can either be fixed by technological advancements over the next 10 to 15 years, as solar, wind decreases in price, or they could be fixed through societal mechanisms like a carbon tax or other ways in which, different types of kind of carbon budgeting or cap and trade that are imposed upon people. But those kind of things are independent of really the research questions. And I think a lot of times in computing, especially in all the kind of mainstream computing conferences, there's this kind of conflation of cost into kind of, whether or not something is viable or useful to do. So I think that's one big problem in computing, is kind of the separation between the research problem and kind of whether this thing is going to be profitable in the near term, or going to be adopted by industry in the near term, without some sort of external mechanism coming in.
Okay, George?
David, if I can, I love that response. I just want to make a quick reaction to that, which is that there was a time when people said no one will use types when they write software because it's too inconvenient, it's too much of a burden. And so obviously we see the benefits of something like types. And excuse me, I'm sorry. And the thing that I've noticed is that in some cases, academics will say, well, no, Google will never do that. Microsoft would never do that because it's not profitable. And then I'll talk to folks at Azure and they're like, actually, that's totally fine. We don't mind. Like, we can move to that. We can throw this out. We can put this in. And so sometimes I feel like we're sometimes creating almost barriers for ourselves, that we have to be more performant, faster, and lower cost and lower energy for people to adopt things. And I think sometimes we should question our own assumptions about some of these barriers to new ideas. And then the last thing I was going to say to your last point was just one thing I think as researchers we can do is, if you can lower the technical barrier to adopting new ideas, that might unlock economic or financial incentives that are currently not possible today. And so we don't necessarily have to, I don't think you have to solve all the economic problems on day one before you begin doing new work.
George, how do you lower those technical barriers? What are your thoughts and others' thoughts on that? What are these barriers?
I think that I'm trying to think of some examples where, for example, there was a big, so with these internet data centers that underpin this cloud environment, there was a big problem with bandwidth, and switches weren't able to keep up with bandwidth. And so largely from the academic sphere, this idea of building so-called fat trees or multi-rooted trees as a data center network technology kind of sprung up. And now that's sort of very commonly deployed. And it adds a lot of complexity. It changes the way you design and build the system. But there was a lot of work to make the control plane more scalable, make the forwarding table better. Now you have programmable chips, et cetera. So there's a lot of work that I think you see deployed that makes a lot of the management and complexity go down. And so now it's possible to deploy a lot of things. Maybe with grids, you're seeing this as well, smart grids. We're moving from a kind of broadcast energy network to a much more dynamic network. And I think there's just a lot of pieces of research that have all gone together to make that more possible. But maybe others here can speak better to that point than I can.
So Norman?
Yeah, so my question is a little bit on a different angle, but if someone has any thoughts to add on the current topic of discussion, I mean, they can, and then I can probably ask.
Yeah, I actually have a question about related to the high level figures of this computing infrastructure or this industry. I think quite a while ago I read about an article saying this: if you put up all the IT sectors power usage together, is like 2% of the world power consumption. Is it still at this level? I mean, these days, I guess the article I read probably is about close to 10 years or so.
I did a lot of work on these statistics recently,
okay,
and
cool.
it's really, it varies a lot depending on who you talk to.
Mm-hmm.
And the estimates, it's definitely still around 2%. You can go, some estimate closer to like 1.5%, and it goes up to 4%. So 1.5% to 4%, with 2 to 4% being kind of the chosen one that I repeat.
I see.
And it is growing at the moment.
So Jay, you want to share?
Sure. I've always liked this, this separation between sustainable computing and computing for sustainability. And so this discussion about what do we do in our systems to get them to be more efficient and so on, that's part of that. But I think one thing that our community has grown into is a lot more of this computing for sustainability. How do we apply into other sectors, agriculture, transportation, buildings, and so on? And that's a good space for us as a community. Another comment I wanted to make is particularly with climate. So one strength of our community is really looking at large numbers and the demand side of the equation, thinking about the large numbers of small consumers rather than the typical energy systems view, which is a small number of large generators and large energy consumers, things like that. But really, we go on massive scale in our world. And even if you look at some of the IPCC efforts on climate and energy modeling, things like that, they're still working on large scale models that have very little detail when it actually gets down to it. I think this workshop could be a great opportunity to reach more deeply into climate modeling and see where data gaps are, where there's opportunities for our methods and our approaches to have a stronger effect on climate discourse and that area.
Okay, sounds cool. Colleen, you want to add something?
Yeah, so that's something that has come up actually also in that industry group that I was talking about. It's like the two halves of the sustainability challenge, and kind of you have to work on both at once. You need to look in and solve the problem of the emissions that you're creating, but also look at the possibilities of what we can support. And I think everybody is on the same page that there are, they call it enablement. There are a lot of enablement opportunities. What's really been lacking is kind of numbers to back up some of these efforts. And that's been a real challenge. We have dozens of companies, And kind of the best people could really come up with was the pandemic case study of reduced emissions due to lockdown, which we all know is not a sustainable case study. And I'm going to paste a link to a paper here that came out. We had these researchers from Lancaster University. They published this kind of really for the industry people, it was a bit of a hot take on kind of the idea that a lot of the emissions findings so far are probably an underestimate, and that these claims of enablement are not well justified. And I think they had a point. So, I kind of took this as a call to action for anybody working in this space: is how can you work together with people to really kind of do a thorough before and after analysis of these sorts of solutions. And I admit, it's a really, sorry for the noise, they're unloading a freight elevator near me. But it's a really challenging problem because you maybe need to be going beyond the horizon of the typical publications that we might have. So if you think about, for example, the challenges in agriculture, I've done some work in smart agriculture. We've shown that you can come up with an improved measurement system by some metrics, but then to show the benefits, you actually need to go through the effort to prototype it and to put it in a field and to have an A/B study and things like that. And it's all very challenging to figure out. And I guess this is something where maybe partnerships are a good place to look, because maybe, the academics get the NSF grants or whatnot for kind of the more basic science. And then the companies, you start to work with companies or local farms or whatever the, cities. Somebody spoke earlier today on working with municipalities. You work with those sorts of organizations to do kind of a deployment study where, like, we made this system, it's been a few years, we deployed it, and now here's our retrospective of how well it worked and some of the learnings.
I think Jay asked a question in the chat: how can we better incentivize those prototyping and deployment activities?
That one is really challenging. That is core to I think the structures that we work with, to who gets promoted for what. I mean, I know that there's this new NSF directorate that's kind of looking at how to better get technology from research to development, but they're new, so I'm really curious to see how that might work out and what others might have to say on that.
So I think I can ask my question now. So that question is this: as a sort of early career researcher, I have certain set of skills, and a lot of different topics excite me. Like, for example, every talk in this workshop was really interesting, and I wanted to work on every single one of the threads. Like in a lot of cases, I read about some project, I find it very interesting, and I want to work on that. But of course, I cannot work on everything, even when my skills are applicable. But I have seen people who are more in their advanced research careers, like all of the panelists here, they seem to have a very, they seem to be very good at picking the projects that they work on and that they have an impact. So as a sort of maybe a graduate student or early career researcher, do you have any advice on how to pick the projects that you work on? I remember one discussion with Jay at one time, and he said, so there is the total impact is basically the change that you are making multiplied by how widely sort of adopted it is or something like that. So you may have some project that is making very minute change, but it is applied to masses, so it can have a huge impact. So in terms of like picking the projects that you work on and determining how like evaluating in terms of their impact and things like that, if anyone has any suggestion on how to think about these things as you build your research career.
So George?
Sure. So I mean, it is a hard thing to do, especially if you're sort of outside of the strike zone of a major conference, because there tends to be a strategy of choosing a research topic where you look at the last several years of the proceedings and you kind of stare at it long enough until you find like a hole, and then you say, I'm going to write a paper that fills that hole, and then it's kind of an iterative process. I think that if you're working kind of from a problem basis, the advice I got, so at Berkeley, you know, Dave Patterson gives this talk about research, et cetera. And one of the takeaways of that idea is to effectively look into the future at various roadmaps and find where some line crosses another line. And that's like an interesting place to rethink assumptions. And so in this world of looking forward related to climate, I think there's a lot of places where lines cross. And so you think about, for example, you know, when we deploy software to the cloud, those environments right now are based on fossil fuels, largely speaking, at least in the last 10 years, where you have guaranteed power, you have battery backups, you have diesel generators, you have all of these resources that make sure that you are going to have a very controlled environment. But if you look into the future, and some of the talks today had these pictures of renewables and wind and solar and stuff, you're in a world where there's going to be a huge variation, a lot of dynamism in energy. And so that's one place where you can start thinking, if I look back at all this research, all of this research was based on these assumptions that are now different. So if I start changing these assumptions, how does that piece of work change? How does this piece of work change, you know, et cetera? So that's at least one strategy to start the brainstorming process.
Yeah, I think I agree with George that actually I think sometimes a problem driven is one way to identify a new topic. I remember Kanam Ramchandran in Berkeley. I think he says many interesting things, but I particularly remember one sentence is that he said good problems find solution themselves. So so if you can find the good problem, I think that's there's halfway to go, or even all the way to go, because they will find the solution by themselves anyway. So I think but of course, I mean, what do we mean by a good problem? There are many good problems there. I think another factor that I always sometimes remind myself and my student is that you need to have some chemistry with the problem. Okay, so for some of the problem, you can look at them, you just don't feel any connection. But for some other problems, even if the first time you look at them, you start to have some thoughts, like driving your investigation a little bit further. I think that could be some of the candidate problem to work on. Yeah, I say. So a couple of the general things I myself sometimes apply is to first either to work with industry, because I think industry people, they are not interested in solving problems. Okay, even if they can avoid a problem, they will avoid the problem. Okay, right? Because they don't care about the problem. They just care whether or not they can deliver the product and the service to customer. And because of that, any problem they try very hard but cannot like bypass, there will be something deep and fundamental, I think, to their business. I think that could be some good problem model, good problems to consider, at least. I observed this by working with people in Microsoft. I think this is one of the way the Microsoft researcher, by talking to product group, they try to identify the problem the product group can avoid. Okay? I think those are maybe good candidate problems. Another way maybe is to just like what George said just now, is to think of, do you have some good good future or good vision that in your mind? And let's say you want to incorporate 100% renewable energy. Okay, this is really cool, you say. And then you try to think away, suppose for now to that, the future I want to go, what are the milestone issues I need to address before I can actually reach there? And all those milestone issues, they can become a really good research problems. Okay, I think that's another way to go. And how to actually filter or distill the thoughts into something concrete. This is the way I really enjoy going to a conference and physically and visit different places. The things is that if you run this idea with 10 people from different field, maybe out of 20 ideas you come out, 18 or 19 of them, maybe out of 10 people, 7 to 8 people, think they are not so cool or anything. But there's 1 or 2 idea. If you talk with people, you'll find most people start to think maybe this start to make some sense. And this is by this iteration process, you improve your problem formulation, definition, and all the angle motivation you might have. I think this can really give you some really cool problems. Okay, yeah. So that's some of my observation over the years. So Jay, do you want to share something? Because I observe your research usually come from quite wild aspects. There's sometimes focus on this like bring this providing this sustainable computing or this good service to underdeveloped countries and regions. So I think that's really cool. And would you mind share some of maybe you can share some of your experience? How do you end up with picking up problems from those angle or those area? Yeah.
So there's 2 things here. One I shared a little bit in the chat, but in kind of understudied and under measured contexts, a lot of developing regions just have really poor data quality. It's often finding an interesting data set and chasing after it, seeing what if you find a data set that you don't think people have studied before, can you combine it with other things and kind of move the world forward that way? As far as what it took to, so my background, I went Ph.D. Working on problems in industrialized regions. Then I went and worked in Kenya for 3.5 years before coming back to academia. And so that was a very formative, but kind of atypical path to academic research. It was at IBM Research, so it wasn't necessarily going too far off the path, but those kinds of experiences, whether they come from internships or job experiences or collaborations, can really, that totally changed the direction of my research. And it's been very valuable to bring those kind of, I would say, external experiences back to what's our community. So that those kinds of opportunities, just jumping outside the world for a while, can bring back interesting ideas. You do need to keep your, it's very valuable to keep your disciplinary home in some senses and find the people you connect with on a technical basis, but at the same time, jumping into different problem spaces, be it sectoral or different countries or whatever else, to understand the core challenges there. I mentioned earlier, if we were to connect with communities outside our own and import some of that, the challenges that are faced, I think that's a really good way to find those kinds of problems. And that's what my experience in Africa, in Kenya, actually brought for me.
Oh, thank you. Colleen, you want to add something? I see you actually typing many things in the chat box.
I was just commenting on the value of internships. It's circling back a little bit on prototyping development activities, that if you have the opportunity to have an industry partnership to work with industry, it might not be 100% transfer of what you're working on, but if it's a good match, then you could send your student to be an intern, and maybe some of the kind of nuggets from where the project overlaps with the industry initiatives will make it into a product. And just I did my PhD at Stanford, so the obligatory acknowledgement that maybe that's the approach if you're not going to start a startup directly.
So I have one thing to add here where, like, even I think, so I feel that there may be in doing so, in my experience, you run a risk of like maybe just focusing on industry problems, and they may be only the problems that serve their immediate needs. At the same time, I remember George at the start of this session saying that industry is quite open, and maybe it's just we who are thinking that they may not be open. So I am still split on this, how these dynamics like come into play when you talk, like when you focus on, when you focus or like put all of your efforts on problems that the industry is interested in, as opposed to like pure research problems that may not be immediately deployed, but they have a huge potential. Because like if you see some of the papers from like this computing industry from like 10-20 years ago, at that time they were not deployed, and maybe industry was not really interested in them, or maybe there was no industry at that time for that particular topic, but they are now basis for like these huge changes. So I am still not like sure how much benefit versus risk of limiting yourself there is when it comes to industry academia partnerships and things like that.
To clarify, I don't think you should necessarily change your research area to target industry, but rather find cases where it organically aligns. And even if you have this alignment, the specifics of a project, there's no guarantee that that's going to be making it into a product at the company. But if you are, I think we're fortunate, our industry, in that ACM venues and other venues tend to have industrial participation. There were a number of industry participants today, and I thank the organizers for inviting us. And we've talked to a lot of researchers in this field, and we've started looking at opportunities for how can we get their students involved, et cetera. And we just happen to be very involved and interested in this project area right now. But we don't think anybody should change what they're working on necessarily.
Yeah, but in some cases, I feel that like reviewers at OSDI and places like that end up expecting that you have a system that is deployed to like at massive scales and things like that. Like the expectations at some of these top level conferences that are dominated by industry reviewers are maybe sometime unrealistic on purely research problems. I'm not saying that like it is necessarily like just harmful. I'm just like thinking that there are still, I mean, some maybe challenges, or maybe some places where there needs to be more considerate effort in making sure that things are progressing in a more fruitful way. I don't know, like David has something to add probably. Like he has hands up.
Mm-hmm. Well, David?
Yeah, I actually don't know if I have anything that useful to add. I would just distinguish between kind of coming up with research problems. Like I think you had mentioned that you look at all these talks and you're like, oh, these are all very interesting problems. and kind of thinking about and centering yourself around like a kind of a research agenda, or something that's longer term, right? So looking at like 10 years out and what is going to be important in 10 years, and kind of working, thinking about problems in terms of like that longer term direction. And so I think, like, for just as an example, at UMass, like we started working on a lot of this sustainability stuff probably 12 years ago, right? And I would say it was a much harder pull 12 years ago than it is now, because now there are a lot of venues, and there's I guess Prashant and Keshav and various people, Minghua, helped to form SIG Energy, and kind of like a lot of that stuff grew out of what was, Keshav did a lot of kind of the work, 12, 13 years ago, kind of starting a lot of that stuff, Prashant. And so now kind of that's grown, and maybe that area is going to grow in, like, even more in the next 10 years, hopefully. But there might be other areas, right, that other kind of 10-year kind of research agendas people might want to look at. And so I would look at things both at kind of the near term, like what do I do next, but also kind of over a longer horizon, and think about where you want to be 10 years from now. What do you think will be important kind of longer term?
Yeah, right. So there is also one thing I observe. So there's some researcher, like what they are doing is that they actually, when they are working on the field, they are actually pretty focused on working only on the problem, the several important problems on this field, and keep working on the problem for a substantial amount of time. And I think one example is Stephen Low. I think many of us know him. I think if you look back at what his research trajectory, he working on networking before, and then focus on congestion control, which is a problem that is the center to networking like research or community, right? And then he started working in power system. Then he focused on optimal power flow, which again is another essential problem in power system operation. So I think this is not a way so to work on problems that is important, but is also challenging, and of course I think there is multiple reasons that why that problem was chosen to be worked. He chose those problems to work, but I think that at least when you observe how the established people sometimes picked up the problems and how their research trajectory, you may get some inspiration from there as well.
Yeah, thank you. Does anyone from the audience have any questions? If not, I would thank all the panelists for being here and discussing all these different topics. And I would leave it to Minghua to conclude the workshop. And yeah, that's it.